Good morning, students. This is Latif sir. In this video, I'm continuing the sixth chapter of class 10 chemistry. The topic is electrolysis. Today, first I'll discuss about electrochemical series. What is electrochemical series? Based on the chemical reactivity of different metal ions or different metals. Metals are arranged in a tabular form, and this tabular form is known as electrochemical series. Generally metal can lose one or more electron, and therefore they can form metal cation easily. In this electrochemical series of metal, you can see some metals like potassium, calcium, sodium, magnesium. These metals are placed at the top of this electrochemical series, and their metal cations also placed at the top of this series. And some metals like copper, mercury, silver, gold, these are less reactive metal, and their metal cations also. So these are the metals like copper, silver, mercury, gold. These metals are less reactive metal, and these metals are placed at the bottom of this series. And some metals like zinc, Fe, nickel, tin, these metals are moderately reactive metals. These are placed in between reactive and noble metals. Okay. And during electrolysis the cations migrate towards cathode. Metal cations generally migrate towards cathode and accept electron and reduce. And according to this electrochemical series, down this series, tendency to accept electron, one or more electron, and tendency to reduce is increases. Therefore, down this electrochemical series, the tendency to discharge at cathode increases. Tendency of different metal cations during electrolysis to discharge at the cathode increases. Okay. So now see some characteristic points about electrochemical series of metal is given here. A metal with higher position in the series displaces the one with a lower position. Second point, metal below hydrogen cannot displace hydrogen from acid, while those above it can. And third point, most important point, which will be used in electrolysis chapter, this point. So elements lower in the series get discharged more easily. Very important point. The element lower in the electrochemical series get discharged more easily at cathode during electrolysis because their cations can easily gain electrons. Very important point. Okay. So this point, third number point, will be used in electrolysis in this chapter. Elements lower in the series get discharged more easily at the cathode during electrolysis because their cations can easily gain electrons. Okay. Now see, similar type of electrochemical series of anion is given here. You can see based on their reactivity, anions are negatively charged ions, and during electrolysis they migrate towards anode, and they loses one or more extra electron at the anode, and therefore they discharged at anode. Okay. So different anions, electrochemical series of different anions, you can see the anions are sulfate, SO42 minus, nitrate, NO3 minus, Cl minus, chloride, bromide, iodide, and hydroxide. Okay. Few anions are given, and they are arranged in this order, and this is known as electrochemical series of anions. And down this series, down the series, tendency to discharge at anode increases. Okay. Down the series, tendency to lose one or more electron at anode, and tendency to oxidize at anode increases. So in this electrochemical series of anion, down this electrochemical series, increase tendency to discharge at anode increases, similar to electrochemical series of metal. Okay, so about electrochemical series of anion here given, lower the position of anion in the series, more easily it gets discharged at anode. Very important point, and this point will be used in this electrolysis. So lower the position of anion in the series, more easily it discharges at anode, and higher the position an anion in the series, higher the position of an anion in the series, more difficult for it to lose electron or get oxidized. Okay, now see preferential or selective discharge of cations or anion at electrode. During electrolysis, you know, cations and anion, cations migrate toward cathode and discharge at cathode, and anion migrates toward anode and discharged at anode. Okay, and the selective discharge of discharge of ions depends on three factors. One is the relative position of the ions, relative position of cation and anion in the electrochemical series. Second factor is the relative concentration of the ion, and third factor is the nature of electrode. So first factor, see the first factor, the relative position of ions in the electrochemical series. So how the selective discharge of ions at electrode depends on relative position of ion in the electrochemical series. Let us explain with the help of copper sulfate solution. Okay, so copper sulfate solution, aqueous solution of copper sulfate, ions are copper sulfate dissociate into copper 2 plus and sulfate 2 minus ion, and water ionized into H plus OH minus ion. Okay, so in the solution, in the aqueous solution of copper sulfate, cations present are Cu2 plus and H plus, and anions present are SO4 2 minus and SOH minus. In the copper sulfate solution, cations present are copper 2 plus and H plus, and anions are sulfate ion and hydroxide ion. Now see, in this solution, two types of cations and two types of anions are there. So at cathode, both copper 2 plus and H plus will migrate towards cathode, and as the position of copper 2 plus ion in the electrochemical series is lower than H plus ion, so copper 2 plus ion migrates towards cathode and discharged more easily at cathode than H plus ion. So at cathode you will get copper metal, and at anode both OH minus and SO4 2 minus ion will migrate towards anode, and as the position of OH minus ion in the electrochemical series of anion is lower than SO4 2 minus ion, so OH minus ion will migrate toward anode, and OH minus ion will discharged at anode more easily. OH minus ion loses one electron at OH minus ion can lose one electron more easily at anode, and therefore it forms OH radical, and two OH radical combine together to form one water molecule and oxygen atom, and two oxygen atom combine to form one oxygen molecule. Okay, so at anode you will get oxygen and water, and at cathode during electrolysis of aqueous copper sulfate you will get copper metal. Okay, now second point, how the preferential or selective discharge of selective discharge of ion depends on concentration of ion in the electrolyte. Okay, so let us explain with the help of an example. Electrolysis of concentrated NaCl solution. Okay, if an electrolyte, remember that if an electrolyte has a much higher concentration of a particular ion, if an electrolyte has much higher concentration of a particular ion, then that ion will discharge at the relevant electrode in preference to those ions which are lower in the electrochemical series but are present along with. Okay, so consider this electrolysis of concentrated NaCl solution. In concentrated NaCl solution, NaCl and both water are present. Okay, so concentration of NaCl is much more. So NaCl will dissociate into Na plus and Cl minus ion, and water will dissociate into H plus OH minus ion. So both Na plus and H plus will migrate toward cathode, and Cl minus and OH minus ion will migrate toward anode. Now see at cathode what you will get. At cathode, between Na plus and H plus ion, H plus ion migrates towards cathode more easily. That is, H plus ion will discharge at cathode, because the position of H plus ion in the electrochemical series is lower than position of Na plus ion. And between Cl minus and OH minus ion, so at anode, between OH minus ion and Cl minus ion, you will see that Cl minus ion will discharge at anode more easily, because although position of Cl minus ion is in the electrochemical series of anion is higher than position of OH minus ion, but as the concentration of Cl minus ion is much more than concentration of OH minus ion, Cl minus ion migrates toward anode more easily, and Cl minus ion can lose one electron to form Cl atom, and two Cl atom combine together to form chlorine molecule. Okay, so during electrolysis of concentrated NaCl, you will get chlorine gas at anode and hydrogen gas at cathode. Okay, and now see how the preferential discharge depends on nature of electrode. In electrolysis, two type of electrodes are used. One is inert electrode, another is active electrode. Inert electrodes do not take part in cell reaction in electrolytic reaction, and active electrodes participate in the electrolytic reaction. Inert electrode like platinum, graphite, these are inert electrode, and these electrode do not take part in electrolytic reaction. Active electrode like copper, nickel, silver, these electrode participate in the reaction. Okay, electrolytic reaction. For example, in electrolysis of copper 2 sulfate solution, if active electrode copper is used, then copper atom is deposited at cathode and copper ion is formed at anode. But if inert electrode like platinum is used instead of during electrolysis of copper sulfate solution, you will get, instead of copper 2 plus ion, you will get oxygen at anode, but you will get copper at cathode. Okay, if you use inert platinum electrode instead of copper electrode during electrolysis of copper sulfate, you will get oxygen gas instead of copper 2 plus ion at anode. Okay, so if you change the nature, if you change the electrode, then you will get different product at the electrode. Now you have to study about some electrolysis of some electrolyte. Electrolysis of molten lead bromide, that is PbBr2. Electrolysis of molten lead bromide, cathode reaction, anode reaction, observation, electrolytic cell, temperature, all you have to remember. So during electrolysis of molten lead bromide PbBr2, the electrolyte used is molten lead bromide PbBr2, and temperature is above 380 degrees Celsius. The melting point of PbBr2 is maintained by continuous heating by a burner. Okay, and this is the electrolysis of molten lead bromide. Here graphite anode and graphite cathode, both cathode and anode is made up of graphite, and this electrolysis is carried out in silica crucible. Okay, and the electrolytic cell is crucible made up of silica. Electrodes are cathode and anode, both are made up of graphite plate, I have told, and this graphite plate are inert electrode. Okay, and ions present in the electrolyte Pb2 plus and Br minus. And electrolytic reaction at cathode, cation migrates towards cathode, so Pb2 plus ion migrates towards cathode and accept 2 electron, and it reduced to Pb metal, okay, lead metal. And at anode, Br minus migrates toward anode and loses 1 electron, and it converted into bromine atom, and 2 bromine atom combine together to form bromine molecule, Br2 molecule. Okay, so at cathode you will get lead, and at anode you will get bromine. Okay, so the overall reaction is PbBr2 implies Pb solid plus Br2 gas. So what you will observe, dark reddish brown fumes of bromine evolve at the anode, and silvery gray metal lead is formed at the cathode. These are two observations of electrolysis of lead bromide. One note is given. Two notes are given here. You can see, since silica is non-reactive, hence an electrolytic cell is made. Hence, an electrolytic cell is made of silica is used in the electrolysis of lead bromide, and it can withstand high temperature and is almost a non-conductor of electricity, and the silica crucible is heated slowly from outside. And one more point is given, the ions formed, you can see, the ions become free when the lead bromide is in the fused state or molten state. Hence crucible is heated from the outside to keep lead bromide in the molten state. Okay, and in this electrolysis of lead bromide, graphite anode is preferred to other inert electrode such as platinum, since graphite unaffected by the reactive bromine vapor. Since graphite is unaffected by the reactive bromine vapor. Okay, now see electrolysis of acidified water. Electrolysis of acidified water plus sulfuric acid, dilute sulfuric acid, acidified water. Okay, so dilute sulfuric acid is preferred because it is non-volatile, while dilute nitric acid, dilute hydrochloric acid are volatile acid. And in the electrolysis of acidified water, electrodes used are platinum foils. Okay, platinum electrodes are used in electrolysis of acidified water. So during electrolysis of acidified water, water ionized to form H plus and OH minus ion. Similarly, H2SO4 ionized to form H plus and SO4 2 minus ion. As dilute sulfuric acid catalyzes this ionization, hence electrolysis of acidified water is considered as an example of catalysis. Okay, so water, so in this case, H2SO4 act as catalyst. Okay, because water is a non-conductor of electricity, it consists almost entirely of molecule, and it is a polar covalent compound and can form ions when traces of dilute sulfuric acid is added. Okay, so in presence of dilute sulfuric acid, the electrolysis of acidified water become faster. Okay, so if you pass electric current through acidified water, then you will see that at cathode hydrogen gas will evolve. Okay, H plus from the solution will migrate towards cathode and accept one electrode to form a hydrogen atom, and two hydrogen atom join together to form hydrogen gas at cathode. And at anode, OH minus ion migrate towards anode and loses one electron. OH minus ion loses one electron, and it converted into OH radical, and two OH radical combine together to form one water and one oxygen atom. Now two oxygen atom combine together to form one oxygen molecule. So during electrolysis of acidified water, you will get hydrogen gas at cathode and oxygen gas at anode. Okay, and during electrolysis of water, the ratio of hydrogen to oxygen volume ratio is 2:1. That is 2 volume of hydrogen gas and 1 volume of oxygen gas you will get. at cathode and anode. Now see electrolysis of copper sulfate solution using platinum anode and copper or platinum cathode. So copper sulfate solution, electrolysis of copper sulfate CuSO4. So cathode platinum anode and copper cathode is used. Platinum or copper cathode is used. So on passing first copper sulfate will dissociate into copper 2 plus ion and SO4 2 minus ion. Okay, and water also ionized to form H plus and OH minus ion. So cathode reaction will be copper 2 plus at migrates towards cathode and accept 2 electron and it discharged, it reduced at cathode. So during electrolysis of copper sulfate you will get copper at cathode. Okay, and anode reaction, what will be the anode reaction? The SO4 2 minus and OH minus ion both migrates toward anode, and the OH minus ion being lower in the electrochemical series as compared to SO4 2 minus ion, OH minus ion discharged at anode, okay, more easily. So OH minus ion at anode loses one electron, one OH minus ion loses one electron to form one OH, and 4 OH radical combine together to form 2 water molecule and 1 oxygen molecule. So you will get oxygen at anode and copper at cathode when electrolysis of copper sulfate is carried out using platinum or copper cathode and platinum anode. Okay, so when the deposition of copper ion is completed, the electrolysis of water take place and hydrogen gas is liberated at cathode and oxygen gas is liberated at anode. And note that the blue color of copper 2 plus ion in electrolyte solution fades due to decrease in concentration of copper 2 plus ion in the solution, and finally the solution become colorless as soon as copper 2 plus ions are finished in the solution. Okay, during the electrolysis of copper sulfate using platinum anode and copper or platinum cathode. Okay, now see electrolysis of copper sulfate using copper electrode. Both cathode and anode both are made up of copper. Okay, electrolyte is same, aqueous copper sulfate solution. Both copper sulfate and water will dissociate into copper sulfate will dissociate into copper 2 plus and SO4 2 minus ion, and water will ionize to form H plus and OH minus ion. Okay, so anode reaction will be at anode. First see the cathode reaction. Copper 2 plus ion will discharge at cathode more easily than H plus ion. Okay, this is because the position of copper in the electrochemical series is lower than hydrogen. So at cathode you will get copper metal. Okay, copper 2 plus ion from solution accept 2 electron and it converted into copper metal. And at anode copper from anode loses 2 electron and it is converted into copper 2 plus ion and it comes into the solution. Okay, so anode reaction is different. If you use both cathode and anode as copper electrode, then you will see that the anode reaction will be different. At anode, copper metal from anode will corrode and come into the solution as copper 2 plus ion. Okay, so SO4 2 minus and OH minus ion migrates toward anode, but neither of them are discharged due to the nature of the anode. Copper loses electron more easily from the anode than SO4 2 minus and OH minus ion, because copper anode itself ionized to give copper 2 plus ion. So you will see that the anode will corrode. Okay, so what will be the product? At cathode you will get copper metal. At anode the product will be anode copper 2 plus ion, copper metal from copper anode loses 2 electron and it converted into copper 2 plus ion and come into the solution. Okay, so product at anode, copper anode keep dissolving during the reaction as copper 2 plus ion, as copper 2 plus ions are formed in the at the anode. Okay, and product at cathode, pink or reddish brown copper is deposited. And note that the electrolysis of aqueous copper sulfate may be acidified with traces of dilute sulfuric acid, and this uh, when both cathode and anode are made up of copper electrode, then the blue color of copper sulfate solution remain unchanged during its electrolysis due to copper electrode. This is because for every copper ion discharged at cathode as neutral copper atom, a copper ion, copper 2 plus ion is released or added to the solution by the anode, and hence total number of copper 2 plus ion remain the same. Therefore, the blue color does not fade during electrolysis of copper sulfate using copper electrode. Okay. And application of electrolysis. Next day I will discuss about application of electrolysis. Thank you, students.